So the tides in Spencer Gulf and Gulf St. Vincent only move water back and forth over, say, 5 kilometers or so, 5 to 10, maximum 10 kilometers back and forth, which is a relatively short distance compared to the total length of the estuary. Okay, so on larger scales, longer time scales, you get a density-driven flow. Okay, so apart from the tidal movement back and forth, you get a persistent horizontal flow, which looks like this. And in inverse estuaries, you actually get an outflow of hypersaline water. Hypersaline means the salinity exceeds the salinity in the open ocean in the bottom layer, okay? And you get a return flow near the surface, okay? So now in larger estuaries like Spencer Gulf, Gulf St. Vincent, is actually that the Coriolis force kicks in. Okay? And so these flows are not strictly vertical, okay? There are also horizontally. And let's have a look at that. Maybe you're confused a little bit. Okay, let's have a look at it. Let's have a look at the density-driven outflow from Spencer Gulf. Okay, this one is more pronounced than the outflow from Gulf St. Vincent, and I'll explain why in a minute. Okay, so let's have a look at the outflow first. So these are the famous salinity measurements from Jeff Lennon et al. 1987 in a Nature paper. Okay, and you can see the salinity near the bottom. Okay, salinity near the bottom, and these are salinity contours. And what you can see is there's an outflow of saline water. Okay, and it only takes place on one side of the estuary. Okay, so the outflow is actually moved here over to the right side, and this is what the Coriolis force does. It produces an outflow on one side and the inflow more on the left side. Still, the outflow is attached to the seafloor. It's more a bottom intensified outflow, and the inflow is more near the surface. But still, you have that clear shift of the outflow over to the eastern side of the Gulf. Okay, and this is how it was derived, the outflow. Okay? This is a density-driven outflow. It's difficult to identify in Gulf St. Vincent because you have very strong tidal flows here in Backstairs Passage. And the tidal flows are so strong they actually mix away the signature of the outflow. Okay, this is what destroys the clear signature of the outflow, is you have a tidal mixing. Okay, so that is the reason why you don't see a clear outflow. All right, so this is the density-driven outflow. It doesn't occur all year round. Okay, and we talk about that on the next slide. So not only it doesn't happen in summer. Okay, so let's have a closer look at this feature.